boundaries. This is going to be a lot shorter. So these occur along all spreading ridges, again, because Earth is more or less kind of spherical. To relieve stress, we have these places where we can't just have that divergent rock moving apart. Like if I were to rip a piece of paper, well, that's flat, that works okay. If I were to, try to rip a soccer ball, it's not going to work quite like that. We're going to have places where it's going to go sideways. That's not the best example either. But anyway, transform boundaries are places where some stress is being released all along this big spreading ridge. So in lab, I think what you end up doing is you have to draw a spreading ridge. Oh, okay, I'm tracing the spreading ridge here, but then it kind of stops. Well, it doesn't, it continues. So this, every spreading ridge is kind of like that on a small scale. It's a big, big, big feature. And they've zoomed in quite a bit here so they can show the transform plate boundaries. But again, the whole thing is like the stitching on a baseball all the way up, where places are being, we have these kinks or cuts where rock is being shifted because, so kind of like steps, I guess, step-like pattern. And they occur on land sometimes and create big earthquakes. They create earthquakes in the oceans too, but if no one lives there, then it's not really a problem. But earthquakes that originate from the Mid-Atlantic Ridge and other spreading ridges in the world are one of the big ways that we use this lightly, because science doesn't really prove things. That's not really our goal, but it's one of those kind of proofs for plate tectonics, discovered back in the 50s and 60s by a woman named Marie Tharp, who was a map maker. And she was bringing up, watch videos on Marie Tharp, actually. I'll go ahead and post one for you too, so it'll be right above as well. She wasn't allowed to go out on the ships that were recording this data because, woman and all that. But once they brought back the data, she made sense of it on a map. Everyone thought she was kind of crazy because continental drift wasn't really accepted in the 50s. They were just like, oh my gosh, don't talk about that. That is just silly. That's girl talk. I actually called it girl talk. But anyway, she ended up coming up with making a map that showed all these earthquake epicenters all along this ridge system that they knew was there, but they didn't know there was movement going on. And yeah, apparently there's enough movement to cause a lot of earthquakes. That means that you have new crust being created, you have movement happening, and yeah, this must be how continents move. She pretty much brought the idea of plate tectonics to the modern world, So the old idea of continental drift was kind of poo-pooed and kind of died more or less with Alfred Wegener, and then Marie Tharp and a few other bright people doing their little bits of research all over the world brought it into, okay, hey, maybe there's some good stuff here with those old continental drift ideas, but now we're seeing that everything is bigger and deeper and involves the oceans, which Alfred Wegener with continental drift could never have imagined that. He didn't. Everything involves the oceans, and the oceans are the conveyor belt. This is where the action is happening. So new crust is created at spreading ridges, destroyed at subduction zones. That's our big conveyor belt. Like you go to the grocery store and you have your conveyor belt, you put your groceries on, that goes to the cashier, dives back under, comes back up towards you, and so on. The groceries are the continents. They don't dive down. They sit on top, and they just are shoved around by the conveyor belt, just like the continents are shoved around by whatever the oceanic crust is doing. So I think that's a pretty good analogy for plate tectonics. What are we talking about now? Transform fault boundaries. All right. Okay, on land. So this is a good example of the San Andreas Fault in Southern California. There's several others though. The North Anatolian Fault is a great example in Turkey, and we're actually keeping an eye on that one because we're expecting a huge earthquake to hit Istanbul in the next few years. It's primed for a big earthquake, which would be absolutely devastating considering the condition of a lot of the buildings there. But I like this picture because this ties all these different plate boundaries together. Kind of shows you kind of where would this be on the Earth? I don't know. This is kind of hypothetical. A lot of things going on here. So we have our continental rift system. We have our transform plate boundaries along a major mid-ocean ridge like the Atlantic. Looks like we have a triple junction there as well that does often occur in the continent. We have a collisional belt like the Himalayas. In fact, a good activity I wouldn't mind having y'all do sometime. Maybe I'll keep this in mind for the future, would be to label each of these situations with a real place on Earth. Go ahead and do this for practice, because again, there will be a matching question on the exam that links different real places on Earth, like the Himalayas, for example, which is what that would be, with Indonesia, for example, or the Mid-Atlantic Ridge, or the East African Rift Valley, with each of these different kinds of plate tectonic boundaries. That could be some good practice there. I just gave you the answer, sorry.